In this tutorial, you will learn about the comparable interface. You will learn how to implement the abstract method compareTo listed in the comparable interface. You will learn compareTo is used to order objects using the same criteria implemented in the equals method. You will learn you should implement comparable to take advantage of the sorting methods in the arrays class. In the interface tutorial, you learned interfaces are used to force classes to adhere to specific guidelines. Interfaces act as a contract. A common interface in Java is the comparable interface. This interface has only one abstract method, compareTo, which accepts an object parameter and returns an int value of 0 if the objects are equal, a positive number if the executing object is greater than the past object, and a negative number if it is less. The compareTo method is used to order objects and should be based on the same criteria as used in the equals method. Let's modify our box class to implement comparable. We decided two boxes are equal if they have the same volume, so we will use volumes to order box objects. I modify the class header to implement comparable, and I will implement the compareTo method. To provide implementation for compareTo, the method signature must match exactly to the signature listed in the interface. compareTo accepts an object type parameter, which must be cast as the type of the class in the method. I store the casted object as a box into the reference variable b. If the box objects have the same volume, the method returns 0. If this box is greater than b's volume, the method returns 1. Else this box's volume is smaller, so I will return -1. My class compiles. If I do not implement the method signature exactly, but instead I create a box type parameter, my class won't compile. I have not followed the contract of the implemented interface. I get a compile error that the box is not abstract and does not override the abstract method compareTo in the comparable interface. In my driver program, I will create 4 box objects and print a message comparing their volumes. And so here are the if statements to compare their volumes. I'll ask B1 to compare itself to B2, and if compareTo returns 0, then I'm going to print a message that they have the same volume. If B1 is bigger than B2, I'm going to print a message saying that it has a bigger volume. Else I'll just print that it has a smaller volume. This is comparing B1 to B2. Now if I want to compare B1 to B3, I can just copy this code. So I've copied the code and replaced B2 with B3. Well, what you should notice is that I'm duplicating code, and when you start to do this, you should start thinking about creating a new method, a helper method, and I'll just pass the 2 box objects to it, and that method will do the comparison and the printing. So I'll create a static method called compareBoxes, which accepts 2 box objects, box 1 and box 2. I'll use the same code I was using before. The box 1 object will call compareTo, and I'll pass it the box 2 address. Now that I've created this helper method, I'll just invoke it in my main method by calling compareBoxes and passing the 2 box objects. I compile my driver class and everything is fine, so now let's go ahead and run it. And here's my output. Remember, when I print a reference variable, it will invoke the toString method, and our implementation for toString prints out the dimensions of the box and the volume. So when I call the compareBoxes method with B1 and B2, a message is printed that they have the same volumes. B1 is bigger than B3, so that message is printed out, and B1 is smaller than B4, and so the smaller message is printed out. You can see by creating helper methods, you can reduce the amount of duplicated code in your classes. Because our box class implements comparable, I can take advantage of some of the sorting methods that come with Java. One of the sorting methods is called sort, which is a static method in the arrays class. So I'll create an array of type box with 4 cells. I insert 4 different box objects into the array. Notice the size and order of the box objects. I can pass the reference to the boxes array to the static method sort in the arrays class. This method will sort the array on the implementation in the compareTo method. Notice that the sort method changes the order of the objects in the boxes array. It doesn't create a new boxes array. It just sorts the objects already in there. So now our boxes array is sorted based on volume of the box object. In order to use this method, you have to import the arrays class from the java.util package. So I've changed our driver program to import the arrays class from the java.util package. I've created an array of type box and loaded the array with box objects. I'll print out the contents of my array, and then I'll pass the array to the sort method, and then I'll print the contents after. And here's our output. The boxes are listed in the order before the sort and then after the sort. You can see that after the sort, the boxes are now in order by volume. A question you may have right now is, why do I have to implement comparable? Why can't I just provide a compareTo method? Well, let's see what happens when we do that. I'll modify our box class and remove the implements comparable clause. My class compiles fine, but when I run my box test program, I get an error that the box class hasn't implemented the comparable interface. The sort method needs to know that you've implemented the comparable interface. That's the only way that sort can be guaranteed that you have a compareTo method. So when you're using compareTo, make sure to implement the comparable interface so that you can take advantage of all the other classes out there that use compareTo. In this tutorial, you learned about the comparable interface. You learned how to implement the abstract method compareTo listed in the comparable interface. And you learned compareTo is used to order objects using the same criteria implemented in the equals method. You learned you should implement comparable to take advantage of the sorting methods in the arrays class.